So now we will learn about model of environment. So before we jump into the example of Bellman equation, let's understand first the model of environment. Okay, so you can see that here I have given example how we represent model of environment. So so in reinforcement learning, this is how we basically represent our model of environment. So basically, let me explain you what is this. So this equation basically refer to the probability of transitioning from state S to state S dash and receiving reward R when taking action A. So it is a key component of Markov decision process and is used in Bellman equation to calculate the expected value of the next state. So in other word, it tells us how likely it is to end up in a particular state and receive a certain reward when we take an specific action in a given state. So that is what it basically represent. Now further, model of environment has been divided into two part. One is model free, another one is model based. So let's understand them one by one. So firstly, model based reinforcement learning. So in this, the agent has complete understanding of the environment it is interacting with. So this means that the agent has a model of the environment that describes the transition dynamics or rewards and then other aspect of the environment. So the agent use this model to plan and make decision about what action to take in order to maximize the expected reward. So let's understand this with an example. So model based reinforcement learning is playing a game of chess. Okay, so in chess the agent has a complete understanding of rules of the game, the possible move it can make and the possible response of its opponent to those moves. Okay, using this knowledge the agent can plan ahead and make decision about what move to make in order to achieve its goal of winning the game. Okay, so this is how model based uh, environment work. Now let's understand the model free reinforcement learning. So in model free reinforcement learning, the agent do not have a complete understanding of the environment. Okay, so that means basically I am in an environment and whom I am interacting with, I have no understanding of that. So this means that the agent does not have a model of the environment that describe the transition dynamics, rewards and other aspect of environment. So instead the agent learned from experience by trial and error. So remember we have talk about this in previous videos also. So here the agent learned from experience by trial and error and uses this experience to make decision about what action to take in order to maximize the expected reward. So the example will be for these type of learning is, let's say, um, I mean this model free reinforcement learning is teaching a robot to walk. Okay, so in this case the robot does not have the complete understanding of physics of the environment or the precise dynamics of its own movement, right? Now instead the robot learns by taking action and observing the consequences of these action over time. The robot learn to adjust its movement in order to move more efficiently and then achieve its goal of walking. So in summary, so the model based reinforcement learning involves having a complete understanding of environment and using this understanding to plan ahead and make decision, while model free reinforcement learning involves learning from experience and using this experience to make decision about what action to take. Now one thing just remember guys, in most real world scenarios you you don't or you wouldn't know the exactly the model of environment is what exactly. So you implicitly infer about the model from the observation and the reinforcement learning to use it to solve some problem that are model free. Okay, So the objective of RL agent is to find optimal policy, either using explicit model, that is model based, or by implicitly inferring the model from action taken from various states, that is model free. So hope you guys have understood what is model of environment and what type of models we deal with in reinforcement learning. In next video, let's implement the Bellman equation and see how it works. Okay.